Hello, today in class we are discussing topics that are covered in section 7.1 and a bit of 7.2 in your textbook. Today we are going to talk about how to come up with formula units and name ionic compounds. So let's review with a question like this. How about if I said, how many valence electrons are in these atoms? I want you to draw a Lewis dot diagram. And then I also would like for you to predict the ion formed. All right, this is all information that we covered yesterday in our notes. Let's begin with the elements sodium and let's try chlorine. All right, so the symbol for sodium is a capital N, lowercase a. And if you look on your periodic table, sodium is found in the first group, which means that it has one valence electron. So to draw the Lewis dot structure, I would draw one dot around sodium. Now, we can agree that sodium is not stable the way that it is because in order for an atom to be stable, it needs to have either 8 dots, meaning that it has a full octet in its outer shell, or it needs to have no dots because it's lost its dots. So for sodium, it is currently unstable. Let's take a look at chlorine. Chlorine is in group 17 or group 7A, which means that it has 7 valence electrons. The symbol for chlorine is Cl. So I need to draw 7 dots around chlorine to represent its 7 valence electrons. Again, chlorine does not have a full set of 8 valence electrons. So is there a way that we could combine these two elements and make everybody happy? Well, if you look at it, sodium, in order to have 8 valence electrons, has two options. It could try to gain 7 electrons or lose the 1 electron that it has. Losing 1 electron is going to be much simpler than gaining 7. So sodium is going to lose its electron, throw it out there to space. So that means that now sodium is Na with no dots and a +1 charge because it has lost an electron. Chlorine could stand to gain an electron because it has 7 valence electrons. If it were to pick up this 1 electron that sodium threw out there and got rid of, then it would be stable. And now chlorine would look like this. Chlorine with a full set of 8 electrons. That 1 electron came from chlorine. And now it has a -1 charge because it's picked up an extra electron. Yesterday, we had talked about that we would name that as the chloride ion because ide means that it has become negative. Sodium would just be called the sodium ion because we don't change the name of the cations, we just write that they are an ion. All right, so this is the partnership that would form. If one sodium atom would give up its 1 valence electron to one chlorine atom, then that chlorine would have a full set of 8 valence electrons like it wants in order to be stable. So the formula unit for this is 1 sodium links up with 1 chlorine to make NaCl. The name for that compound is sodium chloride. Now, rules on writing formula units. You should always put the cation before the anion. It's just bad practice to write it as, like ClNa. Chemists would look at you really funny if you did that because you just always put the cation, the positive ion, first. All right, so let's try this with another set of elements. Let's take a look at magnesium. Magnesium, if you look at it on the periodic table, has 2 valence electrons. And what about if we paired magnesium with fluorine? Fluorine has 7 valence electrons because it's in group 17. Magnesium, not stable because it has 2 electrons, so it's either going to have to lose its 2 electrons or gain 6 more. Fluorine, also not stable because it doesn't have its 8. So if we follow the pattern that we used in the last partnership, and magnesium lost one of its electrons, gave it to fluorine, this fluorine now is going to be F minus 1 because it's picked up an extra electron. It is happy and stable. However, if we take a look at magnesium, still not stable. So what can magnesium do? It can't say, okay, fluorine, take another electron because fluorine's full. But what about if, what about if where there's one atom, because atoms are pretty tiny, there's probably another, if it goes out and finds a second fluorine atom, and donates its additional electron to the other fluorine, like this. So then we've got another fluoride with 8 electrons, and now magnesium has no electrons left. Everybody's happy. This magnesium now has a, +2 charge on it because it's lost 2 electrons. So the formula unit for this compound would be, I needed 1 magnesium and 2 fluorines in order for everything to be stable. This is called magnesium fluoride because you always change the ending of the anion to be "ide." All right, I hope at this point this makes sense, but this is probably looking like it's going to take a while if you have to draw out all these dots all the time to come up with these formula units. So there's actually a simpler way to do this. Let's say that you had calcium and bromine, and you were supposed to come up with the formula unit for that compound, and you didn't want to have to draw your structures. A simpler way to do this is called the crisscross method. So in the crisscross method, you first write down the ions that are going to form. So calcium is in the second column, and we learned earlier in this chapter that everything in the second column likes to be a +2 ion. Bromide is Br minus 1. All right, so we make sure that we've got the cation before the anion because that's how it always works. And then we're going to take these charge numbers and crisscross them. So calcium, there's 1 of them. There's 2 bromines after I crisscross my numbers. You can write it as Ca1Br2, but generally if it's a 1, we just leave it out as an implied 1. And the correct formula for the unit that would form between calcium and bromine is CaBr2. And again, we would call it calcium bromide because it is an ionic compound where electrons are gained or lost. If we would go back to the compounds that we had before and you looked at the periodic table, magnesium likes to be Mg+2 because it's in the second group. Fluorine is F minus 1. Crisscross our numbers, Mg1, F2, which is exactly the formula that we came up with. Sodium, if you look it up on the periodic table, likes to be Na+1. Chlorine likes to be Cl-1. So you crisscross, Na1, Cl1. Perfect. All right, so today we played a game, in class called Just Roll With It. Before we get there, I do want to tell you, in math class, when you have the fraction 2 over 2, you reduce that to be 1 over 1 because 2 and 2 are both divisible by 2. Or if you have 2 over 4, you would reduce that down to 1/2. So if you had a compound that was like magnesium crossing with oxygen. Oxygen likes to have a -2 charge. So I crisscross my numbers. It looks like the formula unit would be Mg2, totally switched what element I had there. Mg2O2. These 2 to 2 tell you the ratio of the elements. So just like you simplify fractions, you have to simplify these to be Mg1O1, and the name for that compound would be magnesium oxide. All right, so today in class, to help us practice writing formula units and naming compounds, we played a game called Roll With It. So in Roll With It, the students were given two pieces of information. The first piece of information looked like this. Maybe this will pop up here. It was a key that tells you what, they've got a 20-sided dice like you see in this picture, and it tells you what each number corresponds to. And then the second piece is this, which is posted to Google Classroom for you. If you had been in class, you would have taken your 20-sided die and rolled them in round 1. And I rolled it for you, and I got the choice of Li plus as the cation and O2 minus as the anion. What you must do is go through and write the proper formula unit like we were just doing in the notes, and then name that. Like if you back here in the notes had rolled an Mg2 plus for your cation and an F minus, when you crisscross those, the formula unit would be MgF2, and then for the name, you would name it as magnesium fluoride. So in order to receive your credit for this activity, you need to go through, don't forget to answer the 3 pre-lab questions that are right here at the top. And then you need to go through for these combinations that I've already pre-rolled for you and write the correct formula unit and the name. Don't forget on the names that you have to end in IDE. If you're stuck on any of these, I would suggest going back to your original list of ions that you made at the beginning of the semester. It'll really help you with some names of these things. Make sure that you reduce these whenever you can reduce them, if it's a 2-to-2 or a 3-to-3 ratio. You can just write this on a separate sheet of paper, take a picture of it and upload it to me, or if you have access to a printer and want to print a copy of this and then scan it in, that's fine. In order to receive your credit, this must be submitted by 8 a.m. on Monday. I hope that you have fun with this activity and it helps you learn how to better write formula units and name